let's test whether or not your naive beliefs about probability are correct. So suppose that the probability of an outcome is known to be 0. Does it mean the outcome will not happen? You will never witness this outcome. So an example, suppose that the doctor tells you that the likelihood that you will live as long as Methuselah was the longest living human being in biblical history, and he lived about 1,000 years. Your probability of living as long as Methuselah is 0. Does it mean you will not live as long as Methuselah? Let's see. Suppose that God has decreed that, well, that every 2 to the power of k born person on Earth is going to live as long as Methuselah. So that means that first born person is not going to live as long as Methuselah, but second person will, third will not, fourth will, fifth, sixth, seventh will not, the eighth will, and so on. So the idea is that 1 will be assigned to the 2 cave burn individual. This, of course, is a deterministic sequence. But so how many successes do we have per 2 trials, right? So if I have number of Methuselahs divided by 2, I get 1/2, right? If I take number of Methuselahs and I had 4 attempts, I get 2 divided by 4, right? The next, if I have number of Methuselahs and I had 8, that would be what? That would be 3 divided by 8. When we calculate probability, at least by that metaphysical limit sense, we took limit as n goes to infinity of the number of Methuselahs over total number of trials. So that means that the number of people will have to be born all the way to infinity. What is that number going to look like? That number will look like limit as k goes to infinity of k divided by 2 to the k. In other words, if I have 2 to the k trials, I will have k successes. But observe that this limit equals to 0. This is a deterministic sequence and it equals to 0. So if I were to apply this limit to the sequence, I in fact have infinitely many Methuselahs, and yet the probability of being born one is 0. In the limit, it will converge to a 0. It will not, for any finite number of trials, be an actual 0. Now, why are you so ready to jump and you think right away that the probability 0 means something cannot happen? Usually, when you think about probability, you imagine that outcomes are somehow uniform, that each trial is indifferent to what happened before, so the distribution will be uniform. You can see that the ones here, the successes, they get wider and wider apart. So it seems that over the number of trials, it's less and less likely to be born in Methuselah. But yes, also in ordinary questions, like when you throw a coin, what's the probability that you will what's the probability that you will throw a coin forever and never see heads? It's 0, right? So it could be that if something has probability 0, it could be that it cannot happen, but it could also mean that it is a sort of miracle, and if it happened, though, nobody would ever believe you that it did. So you see, that's kind of a funny thing about probability and miracle. It could be that something happens, and yet there is Absolutely. So it would be with certainty, with complete, logical, sensible certainty that nobody will believe you that you witnessed it. That is a sense in which probability can equal to 0. Well, how about if something has probability equal to 1? Does it mean that this outcome must always happen every time? By the previous example, we know the answer is no. So the probability of being born not a Metushelach will equal to 1. On the other hand, there might be those that are born non-Metushelachs. Now, let me ask you a truly difficult question. Now, does a unicorn exist? Is it possible to witness a unicorn? So some of you might believe in fairies and say, sure, but most people will say unicorns do not exist. Probability of seeing a unicorn is 0. On the other hand, the probability that, that you fall off a roof and be attracted to the earth by gravity, well, you would imagine the probability of that is 1. Certain things are certain, always happen, certain things never happen, and there are some things in between. So the probability of rain tomorrow might be, 50%, or maybe 70% if you see the clouds, right? So are there events that do not have a probability? Is that possible? Something that is so strange, stranger, more fictional than a unicorn, that has no probability. Well, we have seen that just because the probability equals to 0, it does not logically entail that the outcome, the event, cannot happen. Similarly, if the probability of something is equal to 1, it does not mean that something must always happen. So the probability that you will not be born a Metushelach, given that many people were born, given that 2 to the power of k is large, there is a large k, the probability tends to 1. And yet, there are Metushelachs, right? Just like by the previous example. So just if something has probability equal to 1, it only means that the limit will approach 1. It does not force the number to be equal to, the finite element of the sequence to actually equal to 1. Okay? So the answer is no. Now let me try to ask you a truly difficult question. Right? So you know that some things truly don't exist. They never happen. They are completely unlikely to happen. You never see them through your existence, through the existence of the universe. So perhaps unicorns are such creatures. You never see a unicorn doesn't exist, and therefore there is absolutely no possibility of observing one. 0 probability that you will encounter a unicorn on your way tomorrow to work, if you in fact go to work. Now, maybe tomorrow it will rain. Perhaps the probability that it will rain is 0.7 or 70% chance of rain. Right, so rain is not certain to happen, but maybe likely enough or unlikely enough. Might there be creatures much stranger than unicorns? Creatures for which probability does not make sense. They neither not exist at 0, nor do they certainly exist at 1, or anything in between. There is no probability value assigned to them. Are such creatures possible? Think about it, guys. So, if you are ready, let's look at the answer. To me personally, it is much more surprising that there are situations where probability exists as opposed to those where probability doesn't exist. Because you have all taken calculus. You know that some limits, many limits in fact, do not converge, do not exist. And if we interpret probability as a limit, we expect that some limits will not exist. Let me give you a possible example. How might we simulate an event that has no probability? Suppose that, we consider a match between two boxers. So we have boxer A and boxer B as before. Now, suppose that I am going to try to simulate the infinitely many trials where they are fighting against one another, trials to determine who is stronger, or if they are of equal strength. And the way I perform the trials is I simulate them. So I have a device. And the device will flip a coin. Until I have a consecutive sequence. Of 3 heads. So head, 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 and then the device will make a decision based on the sequence. In other words, if I have head and then tail, I begin from scratch, okay? So then what the device will do, the device will decide the following. If the sequence hasn't occurred, that means A wins. Okay? In other words, until the sequence begins, until I see head, 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 A is winning the round by the simulation, and then 2. As soon as sequence appears, as soon as sequence appears, if I get another head, that means that A wins forever. On the other hand, if B tail occurs after the 3 heads, that means from now on B wins together. Now, I only made 3 heads in order for this to not be decided right away, to make it slightly more interesting. The coin flipped, let's say it's a fair coin, or a simulation of a random number between either 0 or 1. So either 0 or 1 is picked. So what happens? Think about it, guys. What happens? So if I run the experiment, right? If I run the experiment, then doesn't matter what happened here. Let's say I had the sequence of heads. Then from now on, I imagine all the outcomes of the trial are no, so let's say all the other outcomes will be here. A wins, A wins, A wins, A wins. So A will forever win, which means that if head happens here, I will observe that limit as n goes to infinity of NA divided by n will approach 1. It means that sometimes if I see after the first 3 consecutive sequence of heads, I will see another head. That will mean that that boxer A wins all the time, again and again and again, and no matter how many times the boxer has won or lost before, you can see that this limit will converge to 1. On the other hand, if I were to see the 3 heads appear somewhere, and then next is tail, no matter what were the outcomes before, now it is B, 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 and B forever, and that means that now the limit as n goes to infinity of n of A divided by n is 0. So the limit, when you perform the experiment once, the limit seems to be equal to 1. But performing it again might make the limit equal to 0. There is an inconsistency. Of course, some of you might protest, but wait a minute. Well, the probability that I will get a 0 is 1/2, because really once this sequence happens, then the fair coin will decide either head or tail. Then it will be 1/2. True. The likelihood that this limit will be, the likelihood the machine will tell you limit is equal to 0 is 1/2. The likelihood of this limit equaling 0 is 1/2. And the likelihood of this limit equaling 1 is 1/2. But this limit, the limit itself, does not exist, because with repeated experiments, sometimes you get the convergent value to equal 1, and sometimes you get the convergent value to equal 0. So this limit does not stand the repeated experiment test. It's not, the experiment is not replicated, right? What we decided to say when the limit exists is when we have probability. And this limit must exist for an indeterminate sequence all the time, right? This limit must exist all the time, every time you perform this infinite mini trials. In an experiment, the results should be replicatable, but here they are not. So this is a very, perhaps you might say, clumsy example of an event that is very strange. It has probability neither 0 nor 1 nor nothing in between. It is stranger than a unicorn because it has no probability of happening. Neither 0 nor 1 nor anything in between, guys. There is a phenomenon, if you know measure theory, of non-measurable sets. So when you describe the axioms of probability, you can construct very interesting mathematical examples of sets that do not have measure. That's the same as sets that will not, events that have no likelihood of outcome, no probability. I hope that is interesting.